But we're going to be using those as kind of the baseline. So the first problem we're doing, we are on the back of page 36 with the very last problem. We're going to graph 2 sine x. Now, yesterday, just as a reminder, we graphed sine x, and it looked like this. Now, remember from what we talked about earlier in the year, get back in that memory, way back to I think like chapter 2, when you put a number out in front of the function, what does that do to the picture? Stretches it, makes it twice as tall. A number in, well, they're not always going to be twice, it depends on the number. So this multiplies the amplitude. And the amplitude is the height. Okay? Amplitude is the height. So instead of coming up to 1 and -1, this one's going to go to 2 and -2. These aren't going to change. The shape isn't going to change. It's just 2 times as tall. So there you go. That's it. I'm not ever going to mark this wrong, but technically there are arrows on both ends of this, because remember what we talked about yesterday? The curve actually just keeps going and going and going. We're just graphing one period of it. So for this problem, our amplitude is now 2, and our period is still 360 degrees. We didn't do anything to change that. Does anybody remember where we put a number in the equation that would change this? No, not at the end. We have to
multiply by x.
Exactly. If we put a number in here, that's going to change this part of it, right? We put a number in here, that's going to change this part. But as long as the number's out in front, it changes this part. It multiplies the amplitude. So your amplitude is supposed to be 1. This is the starting point. We're going to double it in this case. Easy enough. Let's see what the next one says. -3 cosine. Now, just for fun, I'll put my cosine down here. Now, the cosine, remember, is the one that looks a little different because you split the hill. So the cosine, and you've got it right there on your paper, but the cosine looks like this. So because of that negative out in front, it's going to turn it upside down. So instead of starting up here, like cosines are supposed to, it's going to start down here. Now, let's do our labels. That's our shape. Everybody okay with that? And again, typically we've got arrows on both ends. I'm not going to count it wrong. If you forget them, I forget them half the time. But they're there. Now let's talk about the labels. Are the labels going to change? These are. Now we're going from -3 to 3. Are these going to change? No, because we didn't do anything here. This is where we change that number, or these numbers. So this is still 90, 180, 270, 360. Now, our amplitude is our height. How high are we now? 3. Period is still 360. Amplitude is height. It's always positive. So even though there's a negative out in front, all that does is turn me upside down. The amplitude is still positive. This is like so easy. Let's see, F. Negative tangent. Okay, so I'll put my tangent up here. Tangent looks like that, right? And we don't have any labels on the y-axis because it goes up forever and ever and down forever and ever. So that's it. That's my normal tangent. Now I'm going to graph a negative tangent. Now I am still going to have the same shape. The asymptotes are in the same spot because I didn't change this. But now it's upside down. So instead of going up, it's going to come down. Instead of being an increasing function, it's going to be a decreasing function. Now that one does need arrows, so make sure you're putting arrows on the end of that to indicate that you're shooting up and down. Amplitude, none. Ever. Tangents have no amplitude ever. Period, 180 degrees. Negative 90 to positive 90, 180 degrees. I'm liking this. This seems easy. Oh Lord, look at the next one. Now we got some difference happening. So let's see if we can figure this out. It's a sine curve. And it's right side up. So in other words, it's going to look just like this one. So I'm going to go ahead and put marks. 1, 2, 3, 4. I'm going to go ahead and sketch it in. It's a sine curve. There we go. Now on tests and quizzes, you get half credit for having the right shape. Okay? The other half comes from having the right labels. Now, let's talk about these. What do you think these labels are? 1 and negative 1. The only way those labels change is if you put a number out here in front, right? That's how you change those, and we didn't. Now, there's a number on there. Anybody remember how we handle that coefficient, Ian? Actually, this one stretches it because this number right here divides the period. This number out here, if there is one, multiplies the amplitude. But the coefficient here divides the period. So in other words, you're going to take these normal labels and you're going to divide them all by a half. Well, what does dividing by a half accomplish? Multiplying by 2. So this one won't be 90 anymore. It will be 180. And this one will be 360, 540, 720. Whatever number is in front of x divides the horizontal. These are the labels that you start with every time you have a sign problem. Whatever the number is in front of the x is going to divide all those. In this case, it happened to be a 1/2. Dividing by 1/2 is multiplying by 2. Okay? So, what's our amplitude? 1. What's our period? 720. Perfect. I am erasing my originals because I need more room here. Y equals cosine 2x. All right, this is a positive cosine, so I know my shape, my positive cosine. Right there it is, arrows, I remember them. So we're good with that, right? Everybody's got that shape. Now I need my labels. Well, what are my y-axis labels here? 1 and -1. My amplitude is 1 because there's nothing out here to change it. Right? Now, these numbers are supposed to be 90, 180, 270, and 360. That's what they're supposed to be. But this changes them, right? Divide everything by 2. This number divides the horizontal. So 90 divided by 2, 180 divided by 2, 270, and 360. So my amplitude is still 1, but now my period is 180. Everybody good? Tangent 1/4 x. Okay, so there's my normal tangent. This is a positive. This is a positive, so it's gonna look like that. Put in my curve.
First one was 360.
Now, they're supposed to be -90 and 90, but this number divides these. So what is dividing by a 4th? Multiplying by dividing, Jordan, come on, we gotta get this straight. Dividing by a 4th is timesing by 4/1, right? So this isn't -90, this is actually -360, and this is +360.
You got it right.
So my amplitude is none. I'll write the word none. What's my period? 720 degrees. Start to finish. -360 to +360. Oh Lord, look at the next one.
Yeah.
We've got all kinds of stuff going on. Let's get the shape down first. So it's -2 sine 1/3 x. Now let's not worry about anything right now. 1, 2, 3, 4. Except that negative, because that's going to change the picture, isn't it?
Yeah, it's going to start on
It's
the bottom.
the sign starts at the origin, but this one's going to go down first. So there it is. There's my picture. Now, can we do the vertical labels? These guys right here, what would these be? 2 and -2. Is everybody okay with that? Remember that the number out in front of the function multiplies the height. The normal height is 1. So we're timesing it by 2. Now, these labels are supposed to be, I'll write them down here. These labels are supposed to be this, right?
Yeah.
But I stuck a number in there. So that's going to take all of these and divide them by that number. No, we are dividing by 1/3.
We're multiplying by 3.
That's multiplying by 3. Kids, you got to get this in your head. This number is a divisor. You divide by that. So dividing by 1/3 is not multiplying by 1/3. Dividing by 1/3 is multiplying by 3. So this one's going to be 270.
540.
540. 810.
You have a calculator.
1080.
What if it's 2/3 instead of
Then if you divide by 2/3, you multiply by 3/2. So then if you had 90, it would be 90 times 3 over 2, which is 270 over 2, which is 135. Okay, so what's the amplitude of this guy? The amplitude is 2, and the period is 1080. Jordan?
The amplitude can never be negative.
Never be negative. The negative just turns you upside down. Actually, neither one of these numbers will ever be negative. All right, well, that was a lot of fun. All right, let's look at K. Y equals 1/4 cosine 1/4 x. It's a positive cosine curve, so it starts up here. I know we're just beginning, but we gotta get to a point where we can just pop that down just like this. We're comfortable with our cosine picture, our sine picture, our tangent picture. So we can get half credit just from this. All right, now let's put our labels on. What are my up and down labels? 1/4 and negative 1/4. Which means my amplitude is going to be 1/4. That's the height. So if I were doing this to scale, it would be a little squishy thing, right? Now these labels are supposed to be 90, 180, 270, and 360. But I'm dividing them all by a 4th, which means multiplying by 4. So this one would be 360, 720. These are big numbers. So if I were doing this to scale, it might be really squishy this way, but it would be very long this way, right? So my period is 1440. All right, here we go. 2 tan 1/5 x. So let's start with our tangent picture. It's a positive, so it's going to look like this. Let's talk about that for a minute. I'm going to kind of ignore that guy. The reality is, it stretches your curve out a little bit. It makes it a little straighter, but it's really hard for us to tell with our rough sketches. So you can ignore him. Tangents don't have amplitude, right? So there's no amplitude. So you can ignore that guy, unless he happens to be negative. Then you have to pay attention to him because that will turn the picture upside down. But he doesn't really have any impact on me. This does. Remember, these numbers are supposed to be negative 90 to 90. But you are dividing by a 5th, which is multiplying by 5. So negative 450 to positive 450, which makes my period 900. Very good. We are almost done with the pictures.
Thousands.
Yeah. Okay, so we have y equals tan x, tan 10x. All right, this is another tangent. It's right side up.
9.
So there it is. Amplitude is what? None. Now, to find my period, let's see. These are supposed to be negative 90 to 90. But I am dividing them by 10. So they're negative 9 to 9, which means a period of 18. So again, if I were doing this to scale, this one would be squished. This one would be way spread out. Jordan, you getting it?
Yeah, I'm not.
After your bad, awful day?
Yeah.
What did you eat? Did you track it down or not?
I think it was, I don't know what it was. It was something.
Sine 276. Now we're getting a wacky, crazy fraction. We aren't going to be frightened of it. We're going to handle it. First, we're going to sketch our sine curve. Sine curves, remember, start at the origin. I like to put those dots in. It makes it easier for me. You don't have to. But if I can put those dots in and connect them, I get a nice shape. What's my amplitude? 1. Didn't change it, kids. These are still 1 and -1, right? There's no number out here. This is where the amplitude changes, right out here. Now these are supposed to be 90, 180, 270, 360. Those are the normal sine labels. But they're all going to be divided by 2/7. Did you agree? So 90 divided by 2/7 is 90 times 7/2.
90 times 3.5.
Which would be 630 divided by 2, which is 315.
You relate.
Now I want to show you something. If you did this arithmetic right here, this will always work. So if it helps you, pay attention here. And you got 630, but I did that by just adding 315 because all of these spaces are equal. So if I know this one's 315, this one's going to be 315 later, and this one's going to be another 315, and this one's going to be another 315. This would be what, 1260? So sometimes it's easier to do the addition than it is to do the multiplication, but it doesn't make any difference.
Are we gonna have to do that without a calculator?
Yes, you are. I think you can. I have confidence in you. I'm not going to give you stuff with decimals and weird stuff. Okay, so amplitude is 1, period is 1260. You okay with that? All right. All right, let's see what's on the next page. All right, now, a few days ago, we looked at these buttons on our calculator. This time, the directions say find the exact value. Kids, whenever it says that, find the exact value, it means no calculator. So we're going to try to figure this out without a calculator. Does anybody remember, a few days ago, we were doing some word problems with seagulls on top of lighthouses and all that, remember? What did we say? When did we say we were going to use that button? What would we be looking for when we use that button? What? The angle. We're looking for the angle. This means, anytime you have that right there, it means find the angle. Okay? Now, this is harder than you might think. Part of it's easy, part of it's tricky. I want you to go ahead and draw your coordinate axis system. And the first thing I want you to do is figure out which butterfly bow ties are going to have a positive sign value. Forget the number for a minute, it's positive. Where would the sign be positive. Quadrant 1, absolutely, everything's positive in quadrant 1. But there's another place. These all have 2 answers. Where?
3.
No.
Second.
Second quadrant. Christian, is that a guess, or do you have some logic
I
behind?
know, because opposite of the angle. I knew that.
Yep. Sine is opposite over hypotenuse. Where will the opposite side be positive? Won't the opposite side be positive up here? Another way to think about it, y over r. Where is y positive? Above? So the first thing we're going to do, all these problems have 2 answers. So the first thing we're going to do is figure out where the answers are. So you're going to draw 2 triangles, okay? Then,
Always gonna be 2 triangles?
huh?
Always gonna be 2 triangles?
Yes. Well, unless it's one of our quadrantal angles, and then we'll have to go to the circle. But that only happens when we have zeros and undefineds and stuff like that. All right, so we've got an angle out there. We're going to find an angle. This says find the angle. Oh, I already wrote that. Find the angle. The sine is 1/2. So this is what it looks like. You only need to label one of the triangles because they're going to be exactly the same. Opposite over hypotenuse, right? Well, 1 and 2, this must be root 3. How big is that guy?
30.
That's a 30. We know because of where he's across from.
Yep.
So your answers, the angles that make a sine of 1/2 are 30. One of the answers is 30. And the other answer is,
60.
no. The one that makes a 30 in quadrant 2. If that angle's 30, this one's 30. What is the angle that makes a 30 in quadrant 2? Now think about it before you start blurting stuff out. It makes a 30 in quadrant 2. So this is 180. That's 30. What would this have to be? What would this line right here have to be? 150. Beautiful. So the 2 answers to the problem are 30 and 150. That's tricky. That is tricky. All right. Do I see you tomorrow?
No, you don't.
No, I don't. Okay, the next time I see you, oh my lord, I don't see you till Tuesday.
Tuesday, you have to do Monday off, it's not.